Hi, future math genius! I'm Jojor, and today we're going on a mission to crack the code behind quadratic function. Look at this ball flying through the air. Wait, do you notice that it is actually a parabola? Great, that is quadratic function in action. From basketball shoots to roller coasters, this parabola shape is everywhere. Remember, math is not just on the paper, but it is actually shaping the world around us. But have you ever wondered why some parabolas look like a smile, but some are frowns? Or how a tiny change of the number can totally transform the graph? Well, in this video, we're not just going to learn the graph, but also we're going to see the graph in action. The AI assistant that we're going to use today is Photomath. This little app is like a math superhero. It can scan the equation and then solve it step by step, and even can draw the graph instantly. So, grab your curiosity and follow me. Here are some interesting facts about Photomath you shall know before we go further. Photomath was created by Damir Sabol, a dad looking for a way to help his 3 kids with their maths homework. Even though himself is an engineer with substantial math training, he was still having trouble in explaining the concept to them in an easy and approachable way. That is how Photomath was born. Photomath is an innovative educational app that uses our smartphone's camera to scan and solve math problems instantly. Alternatively, we can type our math problem manually. It will not only give the answer but also show detailed step-by-step explanation, just like a virtual math tutor. Photomath covers a wide range of math concepts, including elementary math, algebra, geometry, trigonometry, statistics, and calculus. And our topic for today falls under relationships and algebra. In this video, we're going to cover 3 learning standards, which are identify and describe the characteristics of quadratic expression in one variable, recognize quadratic function as many-to-one relation, hence describe the characteristics of quadratic functions, and investigate and make generalization about the effects of changing the values of a, b, and c on graph of quadratic functions. However, our great focus for today will be on the last one. Before we start, you should know what is a quadratic function. It is actually any equations that make a U-shape when you sketch it. We also call it parabola. Here is the general form of quadratic function. Fx equal to ax power 2 plus bx plus c. Remember, a, b, and c are like the DNA of parabolas. They control their shape, position, and even their mood. In this case, always bear in mind that a can never be 0. Why? Because if a is equal to 0, then x power 2 will disappear, and it is not quadratic anymore. Look at these 2 graphs. When the function is y equal to x power 2, it produces a happy smile because a is equal to 1, which is positive. However, when y equal to negative x power 2, it produces a grumpy face because a equal to negative 1, which is negative. So now, let's see what happens if a gets bigger or smaller using Photomath. Once you open the app, you'll see 2 options, scan or type. For the first part, we will try to enter the equation manually. First, what we need to do is tap the calculator icon and enter our first equation. we take the example equation of y equal to 2x power 2, where a equal to 2. To add the second equation, press enter. Here we choose the example equation of y equal to 6x power 2, where a equal to 6. Next, tap Show Solution and scroll down until you see the graph, and click on Explore Graph. See, the graphs are generated automatically. Let us look at these two parabolas. The blue one is wider, while the green one is narrower. So, what can we conclude? For the graph of quadratic function, the smaller the value of a, the wider the curved shape of the graph, and vice versa. Next, let's discover how the value of b affects the quadratic graph. We try to scan the quadratic functions for this time. Scanning feature is especially convenient for the long and complex functions. See, the solution will come out in seconds. Let us look at these two functions. For the blue one, the axis of symmetry is at the left, while for the green one, the axis of symmetry is at the right. Finally, for the red one, the graph sits perfectly at the center at y-axis. So, we can conclude that the value of b is actually sliding the parabola left or right. Hence, for a greater than 0, if b is negative, then the axis of symmetry will slide to the right. If b is positive, then the axis of symmetry will slide to the left. It seems like we missed something. What about the value c? Let's try out this function. Y equal to x power 2 plus 2x plus 4. Repeat the same step. Scan it, find the graph, and explore. You see the graph intersect at y equal to 4. Here also given the intersection coordinate with the y-axis, which is 0, 4. So, what we can conclude using the information generated by Photomath is the value of c determines the position of y-intercept. Now, let's put this into the test. I'll show you a quadratic function, and together we will predict how the graph will look based on what we have learned. Before we scan the function using Photomath, let's take a guess. Will it be smiley or grumpy face? Is it wide and fat or tall and narrow? The axis of symmetry slides to the left or to the right. And finally, where is the y-intercept? Ready for the answer? Let's check it out. Alright, based on the graph, it is a smiley face, shift to the right, and intersect at y equal to -5. Did you get it right? Big clap for yourself. Congratulations! You have just mastered quadratic functions with Photomath. Now, let us see what are the relationships between Photomath and graphing of quadratic functions. First, Photomath fosters interactive and effective learning. With Photomath, user can scan or type any quadratic functions and instantly generate perfect graph. No more manual plotting for hours, and no more accidental mistakes that lead to wrong conclusions. Apart from that, Photomath provides a visualized way to learn graphing. Photomath does not only give you the answers, but it turns abstract equations into vivid and interactive visuals. User can see the parabola's width, axis of symmetry, and even intercept. Lastly, Photomath promotes experimental learning without pressure among users. The app creates a platform for experimentation, and it functions like user personal math lab. Users can freely adjust the value and immediately see the effects on the graph. This hands-on exploration deepens the understanding and enhances the retention of knowledge for graphing, as well as remove the fear of making mistakes. In conclusion, we should embrace Photomath as our digital graphing companion because it transforms abstract equations into living and vivid visual math. Photomath is an ideal option to make learning more interactive and personalized, where it can adapt to individual pace with step-by-step explanation. Even though AI-powered tool like Photomath is able to generate accurate graph effortlessly, but we need to use it strategically by first predicting the graph shape, then only check with Photomath to reinforce understanding. Let Photomath be your guide, not your crutch. Use it to explore, to verify, and to grow, but never stop thinking by yourself. Remember, AI is here to light the path, not to walk it for you. That's all from me. Thanks for watching.